In the sketch below, GHIJ and IJKL are kites. GI is parallel to JL. Angle G1 is 34 degrees. Angle H is 120 degrees. And reflex angle L is 238 degrees. Determine the size of angle G2, angle J1, angle J3, angle K1, angle L1, and angle I4. Here we have a lot of information, a lot of angles to find, and a very intricate looking diagram. Please don't let this question overwhelm you. You can tackle a question like this step by step. And remember, we use answers to each part of the question to help us find the next part. So let's start with part A. Determine the size of angle G2. Let's make angle G2 red. We see that it sits in kite GHIJ. So let's make this kite blue. From the diagram, we can see that GH is equal to side GJ. And we know that HI is the same length as IJ. G and I are vertices that sit between adjacent equal sides. So we know the main diagonal runs from G to I. Let's make it green. This shows us that angle G1 over here must be equal to angle G2. So let's make a note that angle G1 is equal to angle G2. And we know this to be true because the main diagonal of a kite bisects the interior angle. We know that angle G1 is 34 degrees. So let's make a note of this, and we say angle G1 is equal to 34 degrees. And we know this because this has been given to us in the diagram. If G2 is equal to G1, and we now know that G1 is 34 degrees, we can now see that G2 must also be equal to 34 degrees. Now let's make our diagram black again, and we can write 34 degrees in for angle G2. Determine the size of angle J1. Let's make angle J1 red. The angle also sits inside kite GHIJ, so let's make it blue again. We know that GI is the main diagonal, so once again, let's make it green. Now we can see that angle J1 and angle H, let's make it purple, both sit opposite the main diagonal. So we know that angle J1 has to be equal to angle H. And as our reason, we say the angles opposite the main diagonal of a kite are equal. We know that angle H is 120 degrees. So let's make a note of it over here. So we can say H is equal to 120 degrees because this has been given to us in the diagram. So we can see that angle J1 must also be equal to 120 degrees. Determine the size of angle J3. Let's mark angle J3 in red. It sits in kite IJKL. So let's make this kite blue. From the diagram, we can see that JK over here is the same length as JI, and LK is the same length as LI, which means that JL is the main diagonal in the kite. So let's make it green. We know the main diagonal bisects interior angles and cuts them into two equal halves. So the main diagonal cuts J into J2 and J3. So J2 is equal to J3. So let's make J2 red as well. Now we know that angle J2 is equal to J3, but without the size of angle J, we can't find the size of these angles. We may be able to find the sizes of L1 and L2 down here, but only the angles opposite the main diagonal are equal. So we cannot use this to help us find angle J. We've not been given the sizes of any other angles inside kite IJKL that can help us to find the size of J3. So let's make this kite black again. In parts A and B, we had enough information to find the sizes of the unknown angles directly. But in this case, we don't have enough information to do so. So to tackle part C, we need to look at what we know and what we've been given. We know that angle J2 is equal to J3, so let's leave it red. J2 and J3 sit on either side of the main diagonal JL, so let's make this diagonal blue. The question tells us that GI is parallel to JL, and we can see it over here and over here. So let's make GI blue as well. We know from our work with parallel lines that along with the transversal line, we can use angle relationships to find equal angles. So let's start with our transversal line. Remember that a transversal line touches both parallel lines. In our diagram, we can see that IJ is the only line that touches both parallel lines. So let's make IJ purple. Now we've created a Z shape, and angle J2 sits inside the Z shape, but we also see that angle I2 sits inside the Z shape. So these are alternative angles, which means that J2 is equal to angle I2. Angle I2 sits inside kite GHIJ, and we already have quite a bit of information for this kite. Now we have an idea of how to solve this question. We need to find the size of angle I2. With this, we can find the size of J2, which means we can find J3, the angle we're looking for. So let's make our whole diagram black again, so we can focus on angle I2. Let's make it red. Angle I2 sits inside kite GHIJ. So let's make this kite blue. From part A, we already know that GI is the main diagonal. So let's make it green. The main diagonal bisects interior angles, which means that I2 over here is equal to angle I1. So to find the size of angle I2, we first need to find the size of the whole of angle I. Let's make it purple. A kite is a quadrilateral, and we know that the sum of the interior angles of a quadrilateral is equal to 360 degrees. And we can use this to find the size of the whole of angle I. So we can say in GHIJ, the size of angle G plus angle H plus angle I plus angle J1 gives us a total of 360 degrees. And as our reason, this is because these are the interior angles of a quadrilateral. Now we can make a note of all the sizes of the interior angles we know. We know that angle G is 34 degrees plus another 34 degrees, which gives us a total of 68. So angle G is equal to 68 degrees. We found this in part A. So as our reason, we say proven above. We know that angle H is 120 degrees. So we can say H is equal to 120 degrees because this information has been given to us. And in part B, we found that J1 is also 120 degrees. So we can say angle J1 is equal to 120 degrees. Again, we don't have to prove this, so we use proven above as our reason. Now we can put these values into the equation. Angle G, 68 degrees, so we say 68, plus angle H, 120, plus angle I, say plus angle I, the angle we're looking for, plus angle J1, 120, gives us a total of 360 degrees. Now we have an equation we can use to solve for I. Let's take our calculator. 68 plus 120 plus another 120 gives us 308 degrees, which means that 308 plus angle I gives us a total of 360 degrees. Now, to solve for I, let's subtract 308 from both sides, and we can see that I is equal to 52 degrees. This is the size of the whole of angle I. So let's make some space and make a note that we just found that angle I is 52 degrees. Now we can find the size of angle I2. We know that angle I1 is equal to angle I2. So let's make a note up here. Angle I1 is equal to I2. And as our reason, this is because the main diagonal of a kite bisects interior angles. So if the whole angle of I is 52 degrees, then angle I2 must be half of that. So we can see that angle I2 must be equal to 26 degrees. On our diagram, let's make the kite black again. Let's take out the purple arc. Let's write in 26 degrees for angle I1 and for angle I2. Now that we know that angle I2 is 26 degrees, we know that angles J2 and J3 will also be 26 degrees, but we need to prove it mathematically. We know that GI is parallel to JL. So for the sake of explanation, let's make our parallel lines blue again. And we can make our transversal line purple. Angle I2 and angle J2 sit inside the Z shape. So let's make these angles red again. Now we can make the statement that angle J2 is equal to angle I2, because these are alternative angles. But we also need to give a reason why these are alternative angles. In this case, these are alternative angles because GI is parallel to JL. And we know that this is true because this information has been given to us in the question. We now know that angle J2 is equal to 26 degrees. Now on the diagram, let's take our parallel and transversal lines out and write in 26 degrees for angle J2. We're almost done. We need to find the size of angle J3. So once again, let's make it red. Angle J3 sits in kite IJKL. So let's make the kite blue again. Again, we can make the diagonal JL green. We know that J3 is equal to angle J2. And as our reason, we say because the main diagonals bisect interior angles of a kite. So if J2 is 26 degrees, then we know that angle J3 must also be 26 degrees. Now we can make our diagram black again, and we can write 26 degrees in for angle J3. Determine the size of angle K1. Let's make K1 red. K1 sits in angle K in the kite IJKL. But even though we now have the sizes of angles J2 and J3, we don't have enough information to find the size of K1. Straight away, we can see that JI is the same length as JK. So angle K1 sits in triangle IJK. So let's make this triangle blue. We have the size of angle J. So let's see if we can use the interior angles of a triangle to find the size of angle K1. So we can say in triangle IJK, we know that angle I3, so let's say angle I3 plus angle J plus angle K1 gives us a total of 180 degrees. And as our reason, we say because these are the interior angles of a triangle, we don't know the size of angle I3. So let's look at the whole of angle J. We know that J2 is equal to J3. So let's make a note of this. J2 is equal to angle J3. And these are both equal to 26 degrees. Angle J is made up of angle J2 and J3. So we can say angle J is equal to J3, 26 degrees, plus J2, 26 degrees, which gives us a total of 52 degrees. Let's fill this into our equation, and we can now say angle I3 plus J, which we know is 52 degrees, plus K1 gives us a total of 180 degrees. We need to find the value of K1, but to do this, we need the value of angle I3. We know that IJ is the same length as KJ because this information has been given to us in the diagram. This means that IKJ is an isosceles triangle with two equal sides and two equal angles. If IJ is equal to KJ, then we can see that angle I3 will be equal to angle K1. So let's say angle I3 is equal to angle K1 because these angles lie opposite equal sides. If angle I3 is equal to angle K1, we can rewrite our equation as K1 plus K1, which gives us 2 multiplied by angle K1 plus 52 degrees, gives us a total of 180 degrees. Let's quickly make some space and rewrite our equation up here. Now we can use this to find the size of angle K1. So let's subtract 52 degrees from both sides, and we get 2 multiplied by angle K1 is equal to 180 minus 52, which leaves us with 128 degrees. Now let's divide both sides by 2, and we see that angle K1 must be equal to 64 degrees. Now we can make our diagram black again. Let's put 64 degrees in for angle K1 and for angle I3 as well. Determine the size of angle L1. Angle L1 sits on our diagram at vertex L. Let's make it red. We've also been told that the reflex angle L is 238 degrees. This means that 238 degrees is the size of the angle on the outside of the kite. So let's make a note that angle L is equal to 238 238 degrees because this information has been given to us in the question. From our work with angles, we know that if we take all the angles around a specific point and add them together, we will get 360 degrees. Here, L1 plus L2 plus the reflex angle of 238 degrees all lie around vertex L. So we can say angle L1 plus angle L2 plus the reflex angle L is equal to 360 degrees. And as our reason, we say these are the angles around a point. We know that angle L is 238 degrees. So we can put this into our equation and we get angle L1 plus angle L2 plus 238 degrees is equal to 360 degrees. Now angles L1 and L2 both lie inside the kite. So let's simplify this equation by subtracting 238 from both sides. On the left, we now have angle L1 plus angle L2 is equal to, let's take our calculator, 360 minus 238 is equal to 122. So we get 122 degrees. Now angles L1 and L2 lie inside the kite IJKL. So let's make the kite blue. We know that JL is the main diagonal, so let's make it green. We also know the main diagonal bisects interior angles, so we can see that angle L1 will be equal to angle L2 because the main diagonal bisects the interior angles of a kite. So if the whole of angle L1 and L2 is equal to 122 degrees, then L1 and L2 must be half of 122 degrees. So we can see that L1 must be equal to 61 degrees. Now we can make our diagram black again. Let's put 61 degrees in for angle L1 and for angle L2. Finally, part F says determine the size of angle I4. Let's start by making I4 red. Now, there are a few different ways that you can use to find the size of an angle. The most important thing to remember is to always use the simplest way and work with what you've been given. In the diagram, we can see that IL over here is the same length as LK. So this creates an isosceles triangle IKL. So let's make this triangle blue. Now we have an isosceles triangle and the sizes of angles L1 and L2. So we can use the interior angles to find the size of angle I4. We know that in triangle IKL, angle I4 plus angle L1 plus angle L2 plus angle K2 gives us a sum of 180 degrees because these are the interior angles of a triangle. We already know that L1 plus L2 is 122 degrees. So we can make a note that L1 plus L2 is equal to 122 degrees. We proved this in part E. We don't need to prove it again. So as our reason, we simply say proven above. Now let's put these values into our equation. We have angle I4 plus L1 plus L2, which we know is 122 degrees, plus angle K2, and this is all equal to 180 degrees. We want to find the size of angle I4, but to do that, we need the size of angle K2. We know that IL is equal to KL, so let's make a note of this, and we can say IL is equal to KL, because this information has been given to us in the diagram. So this is an isosceles triangle with two equal sides and two equal angles. If IL is equal to KL, we can see that angle I4 is equal to angle K2, because these angles lie opposite equal sides. Now we can see that I4 is equal to K2. So now we can say angle I4 plus angle I4, which gives us 2 multiplied by angle I4 plus 122 degrees is equal to 180 degrees. And now we can solve for angle I. Let's subtract 122 from both sides. On the left, we have 2 multiplied by angle I4 is equal to, now let's take our calculator, 180 minus 122 is equal to 58. So 2 multiplied by angle I4 is 58 degrees. Now, to get angle I4 by itself, we divide both sides by 2. So on the left, we have angle I4 is equal to 58 divided by 2. Let's take our calculator. 58 divided by 2 is equal to 29. This is the size of angle I4. And we have now completed this question.